Hi Gigs.
Hi Tara, how come you're here today?
This summer has brought extreme temperatures this year and our building heats up too much, therefore looking for a change.
True, I understand your pain, but it's not so easy as you think.
True, as you are a builder, can you throw some light on whether Zig Zag wall help buildings to beat the heat? I mean Zig Zag walls.
Good question, Tara. Zigzag walls, or buildings with zigzag or angular facades, can indeed help with heat management and overall building performance. This design approach, often used in architecture, has several benefits related to thermal regulation, although it's not a one-size-fits-all solution. Zigzag walls can contribute to beating the heat by enhancing ventilation, reducing solar heat gain, and providing thermal buffering. However, their effectiveness is influenced by various factors, including building materials, local climate, and overall design strategy. I hope you understood. Thanks.
Can you just brief how it works?
For an improved natural ventilation, zigzag or angular walls can create dynamic airflow patterns around the building. The irregular shape can help facilitate cross-ventilation by allowing cooler air to flow through different openings and circulate around the building more effectively. For a stack effect, the design can enhance the stack effect, where warm air rises and exits through higher openings, drawing cooler air in from lower levels.
Do the zigzag walls also help in reducing solar heat gain?
Zigzag walls can provide more shading to the building's interior by breaking up direct sunlight and reducing the amount of solar radiation that hits the building's surface. This can lower the amount of heat absorbed by the building. The angled surfaces can reflect sunlight away from the building, minimizing the heat absorbed by walls and windows.
Do the zigzag building also help in insulation?
Good question. If zigzag walls incorporate materials with high thermal mass, they can help moderate indoor temperatures by absorbing heat during the day and releasing it at night. This helps stabilize indoor temperatures and reduces reliance on air conditioning. The design can create pockets or recesses that act as thermal buffers, helping to insulate the building from extreme temperature fluctuations.
Any environmental benefits associated with zigzag walls?
Zigzag walls can enhance the aesthetic appeal of the building, making it stand out and potentially contributing to its overall environmental integration. By reducing the amount of heat absorbed and re-radiated by building surfaces, zigzag walls may contribute to lowering the urban heat island effect, where urban areas become significantly warmer than their rural surroundings.
Thanks. Can the walls be tailored to optimize passive solar gains?
The design of zigzag walls can be tailored to optimize passive solar gain. By carefully orienting the building and its walls, architects can take advantage of natural sunlight for heating while minimizing overheating during hot periods. The irregular facade can be designed to control sunlight exposure more precisely, balancing between maximizing daylight and minimizing heat gain.
Good one. Any limitations and considerations?
Zigzag or complex wall designs can increase construction costs due to the need for specialized materials and labor. Irregular surfaces might require more maintenance or cleaning compared to traditional flat walls. The effectiveness of zigzag walls in beating the heat depends on the local climate and specific design implementation. In extremely hot climates, additional measures like green roofs or high-performance glazing may be needed.
Thank you so much.
Welcome. I am going towards your location. If you want, I can drop you.
Thanks you, but my questions won't stop.
Ha ha ha. Tell me, what are the other questions relevant to buildings in your mind?
Thanks. Since this year was extremely hot, I hope you and your real estate stakeholders will be looking other ways out to beat the heat of buildings.
Beating the heat in buildings involves a combination of design strategies, materials, and techniques to manage and reduce indoor temperatures. We do keep adapting into changes required.
What are the effective methods other than zigzag buildings to keep buildings cooler?
Position the building to minimize direct exposure to the sun, particularly during peak sunlight hours. Orient windows and other openings to take advantage of prevailing winds for natural cooling. Use overhangs, awnings, pergolas, or louvers to block direct sunlight from hitting windows and walls. This can significantly reduce solar heat gain.
What about passive cooling techniques?
Design windows, vents, and other openings to facilitate cross-ventilation and stack ventilation. This allows cooler air to enter while warm air exits, reducing indoor temperatures. Incorporate materials with high thermal mass, like concrete or brick, that absorb heat during the day and release it at night. This helps moderate temperature fluctuations. Install vegetation on roofs and walls to provide natural insulation and reduce heat absorption. Green roofs also help with stormwater management and air quality.
What about proper insulation?
Ensure walls, roofs, and floors are well insulated to prevent heat transfer between the outside and inside. High-quality insulation reduces the need for cooling and helps maintain comfortable indoor temperatures. Use reflective or cool roofing materials that reflect more sunlight and absorb less heat. White or light-colored roofs can help lower indoor temperatures by reducing heat absorption. Apply reflective window films or tints to reduce solar heat gain through glazing. Specialized coatings can also improve energy efficiency significantly.
What about energy efficiency of windows?
Install windows with low emissivity (low-E) coatings that reduce heat transfer while allowing natural light to pass through. Use double or triple glazed windows to improve insulation and reduce heat transfer.
Does high quality of air conditioning play a game?
Use energy-efficient air conditioning systems and ensure they are properly maintained. Consider programmable thermostats to optimize cooling schedules. Use ceiling fans to improve air circulation and make indoor spaces feel cooler. Fans can be used in conjunction with air conditioning to increase comfort while reducing energy consumption.
Thanks so much. Anything which exterior treatments can help.
Apply cool pavement materials or coatings on driveways and walkways to reduce heat absorption and lower ambient temperatures. Plant trees and shrubs around the building to provide shade and reduce the heat absorbed by the building's exterior. Landscaping can also help cool the surrounding air.
Good one. Now most important thing is building materials. What can help us?
Use heat-resistant or reflective materials for building exteriors and roofs. Materials like insulated panels, reflective coatings, and cool roofing can significantly impact temperature management. Opt for light-colored paints and finishes that reflect more sunlight and absorb less heat compared to darker colors.
What is this I hear nowadays? Smart building techniques.
Implement BMS to optimize energy use and control cooling systems more effectively. BMS can manage lighting, HVAC, and other systems based on real-time data and occupancy. Use automated shading systems to adjust blinds or shutters based on sunlight intensity and time of day. BMS's building management system.
Thanks a lot for your good replies. Now the last one, that is maintenance.
Regularly service HVAC systems, insulation, and other cooling-related components to ensure they are functioning efficiently. Inspect and seal any gaps or leaks in windows, doors, and ducts to prevent cool air from escaping and hot air from entering.
Thank you so much. So now my understanding is, by employing these strategies, you can effectively manage and reduce heating buildings, leading to increased comfort and energy efficiency. Combining several methods often yields the best results, tailored to the specific needs and conditions of the building.
You are right, you got it. Thank you, bye-bye.
Thanks for dropping me. Good day.